Hello and welcome to this second part of the video where we're going through AQA's GCSE Mathematics Foundation paper from November 2019, and a reminder this is paper 2 and it's a calculator paper. We left off with question 13, which means we are starting now with question 14. Question 14. Circle the solid that has 6 vertices. So to begin with, we need to know what each of these solids are. We've got a cone, a cuboid, a triangular prism, and a square-based pyramid. I have drawn each of these shapes so that we can see what the different features are. So to begin with, a vertex is the point or corner on a 3D object. The plural word, so meaning more than one of them, is vertices. If we look at the cone has only one vertex, which is the point right at the top. So a cone has one. A cuboid will have 1, 2, 3, 4 on the front, and then on the back we'll also have 1, 2, 3, 4, meaning a cuboid has 8 vertices. A triangular prism has 3 on the front, but also 3 on the reverse. So that has a total of 6, which means triangular prism is going to be our correct answer. But just to finish off, a square-based pyramid has 1 vertex at the top and a following 4 going around its base. Question 15. Which of these fractions is closer in value to 1, 3/4 or 13/10? You must show your working. The easiest way of finding which of these values is closer to 1 is to convert them both into decimals. The easiest way to do that is to take the top number and divide it by the bottom. So the numerator divided by the denominator will give us the decimal of 0.75. And remember, this was a calculator paper, so that calculation could have been done using that. For 13/10, we're doing 13 divided by 10, which is 1.3. We now need to decide which of these two numbers is closer to 1. Once again, if I draw myself a number line and I put the number 1 onto it, I can place 0.75 below it and 1.3 above it. And I'm just trying to figure out which of these two distances is the smallest, because that will tell us which one is closer. To get from 0.75 up to 1, we are 0.25 away, and to get from 1 to 1.3, we are 0.3 away. 0.25 is smaller than 0.3, so 3/4 is closer to 1 than 13/10 is. Question 16. 3 teams, A, B and C, play in a competition. The ratio of the games won by A to the games won by B is 2:1. The ratio of the games won by B to the games won by C is 3:1. Team B won 6 games. In total, how many games have the 3 teams won? When I'm answering ratio questions, I use a bar model. A bar model is a picture or diagram that represents the ratio that we can then fill in with numbers from the question. Now, each bar model should only represent one ratio, so since we have 2 ratios, I'm going to need 2 separate bar models. Okay, so to set up the first bar model, since the ratio of A to B is 2:1, I've given A 2 bars and B just 1. For the second ratio of 3:1 for B to C means I've given 3 to B and 1 to C. We are told that Team B wins 6 games. So this number 6 for the first ratio is being represented by one single box. So that means that that box must be worth 6. Since I know that that box is worth 6, so are the 2 for A, which means that in total, A has won 12 games. For the second ratio, we are once again told that Team B has won 6 games. Now this time, this is being represented by 3 sections, 3 boxes. So we need to divide the 6 equally into 3 parts to say that each one of them must be worth 2. So each of these is going to be worth 2, and so is the one for C. So C is going to win 2 games. Now we need to find out how much they have won in total. So A won 12. B, we know, won 6. And C won 2. And so 12 plus 6 plus 2 means in total the 3 teams won 20 games. Question 17. Match each expression in column P with the equivalent expression in column Q. One has been done for you. So the one that's been done for us is a squared times a to give us a cubed, because the powers will add together. So 2 plus 1 will give us the power of 3. For the second one, we're only dealing with 2a and multiplying that by 3. Dealing with the numbers, 2 times 3 gives us 6, and there's nothing to change the powers, so that means it's just going to be 6a, which is the top option. For the third one, we've got 12a squared divided by 2. So once again, 12 divided by 2 is 6, and there's nothing to change the power on that a, so that's going to be 6a squared, which is the bottom option. And finally, 10 multiplied by a half a squared. Well, dealing with the numbers, 10 times a half means half of 10, which is 5. Once again, there's no a's to change the power involved with the a squared, so that's going to be 5a squared. Question 18. A drink is made by adding water to juice. The instructions say add an amount of water that is between 2 times and 3 times the amount of juice. Rana has 120 milliliters of juice. She adds some water. She has now made 450 milliliters of the drink. Has Rana followed the instructions? You must show your working. So to begin with, Rana has 120 milliliters of juice. She's adding an amount of water and ends up with 450 milliliters of the drink. So we can work out how much water was added. You can do 450, subtract the 120 to notice that we are adding 330 milliliters of water. We need to show whether or not 330 milliliters of water is between 2 times and 3 times the amount of juice. So the amount of juice is 120 milliliters. If we do that 2 times, we'll get 240 milliliters. If we do 120 3 times, we get 360. And the question is the number 330 between those two values? And the answer is yes. 330 is bigger than 240, but less than 360. So yes, Rana has followed the instructions. Question 19. A rhombus is cut along the diagonals to make 4 triangles. Which of 3 statements are correct for any rhombus? Tick 3 boxes. Right, to begin with, when we have a rhombus, these lines that are the diagonals that are being cut across are also the lines of symmetry, which means that one half is exactly the same as the other half, but in reverse, a reflection. It same goes for the other half at the top and the other half at the bottom, which means that when we split this into 4, all 4 of those triangles are going to be the same as each other. And when we say that 4 things are the same as each other, we are saying they are congruent. That word congruent just means the same. Now that allows us to find some more information out now. Since we know that all four triangles are the same as each other, we should also be able to say that the area of the rhombus in total is going to be the same as 4 times the area of one triangle, because each of the 4 triangles are exactly the same, which means they have the exact same area. And finally, once again, since we know that all these triangles are the same, if I go to this diagram at the top, it means that these 4 angles also have to be the same. Angles around a point have to add up to 360, almost forms a full circle around it, which means that if they have to do the same and they are split equal into 4, 360 divided by 4 is 90, which means that all 4 triangles must contain that 90-degree right angle. Question 20. The map of an island is shown on a centimetre grid. A, B and C are houses. The actual distance between A and B is 1,500 metres. Show that the scale on the map is 1 to 30,000. So to begin with, we're looking at the distance from A to B. Now on the diagram, the map, that is 5 centimetres, 5 squares. We're also told that in real life, that distance is 1,500 metres. So we can say that as a ratio from the map to real life will give us the ratio of 5 centimetres to 1,500 metres. And we can now simplify this. Both 5 and 1,500 can be divided by 5. If we do that, we can simplify this ratio to 1 centimetre and 300 metres. That just means that every time you are moving 1 centimetre on the map, you are actually travelling 300 metres in real life. Now when we have a ratio, we need to try and make sure the units are equal to each other. At the moment we've got centimetres and metres, we need to make them the same. Well, there are 100 centimetres in 1 metre, which means that if we are changing from metres to centimetres, we are multiplying by 100. So if I multiply 300 metres by 100 and 1 centimetre, apologies, move this down as well, restarting. So we've got 300 multiplied by 100 will be 30,000 centimetres to 1 centimetre. And we have now shown that the scale is 1 to 30,000. Part B. Work out the actual distance between A and C. Give your answer in kilometres. Right, there are 2 ways that you can do this. We can do using a measurement and proportion, or you can use Pythagoras as well. I'm going to show both methods. So to go from A to C, we are travelling along that line there. If we measure that line, you will see that the actual distance is 4.5 centimetres. So 4.5 centimetres is our actual distance, so that's what we're going to try and get to. From part A, we found out that 1 centimetre on the map was actually 300 metres in real life. If we multiply this by 4, we can find out that 4 centimetres will be 1,200 metres. If we half our original amount, so half of 1 is 0.5 centimetres, half of 300 metres is 150 metres. which means that if we have 4 plus 0.5, we can say that 4.5 centimeters, and add these two values, we'll get 1,350 meters. It tells us it wants us to give the answer in kilometers, and there are 1,000 meters in a kilometer. So if I divide this by 1,000, we'll get the answer of 1.35 kilometers. If we're doing this question using Pythagoras, we are also going to need to make sure that we have a right-angled triangle. Now the distances on this triangle, since this is 2 squares, that means that's going to be 600 meters, because 1 square is equal to 300 meters. Along the bottom, we've got 4 squares, which would be 1,200 meters. Now Pythagoras says that we have got a squared plus b squared to be equal to c squared, where a and b are the two shortest sides, and c is the hypotenuse, which is directly opposite from the right angle. So this would be our value for c along that line, and that's the distance we are trying to find. So substituting a and b, we can say this should be 600 squared plus 1,200 squared to give us the value of c squared. Since it's a calculator paper, you can work that out as 1,800,000. That's equal to c squared. And so to work out the value of c is going to be equal to the square root of 1,800,000, which is 1,341.640786. This is in meters. So once again, to convert that into kilometers, you need to divide it by 1,000 and also maybe round it to some sort of degree of accuracy. I'm going to write that as 1.34 kilometers. What you'll notice is that using the two different methods, we actually ended up with two slightly different answers. Both of these were accepted by the mark scheme and the examiners during this exam. Question 21. A and B are both prime numbers. They are each less than 20. Give an example where A plus B is odd, but not prime. Well, first of all, let's define what a prime number is. A prime number is a number that has exactly 2 factors. No more, no less. It means that it can only be divided by 1 and itself. So our first step is to write down some prime numbers. 1 is not a prime number because it only has itself as a factor. Only one factor. So 1's not prime, but 2 is. You can divide 2 by 1 and 2 and nothing else. The following prime numbers after 2 will be 3, 5, 7, 11, 13, 17, and 19. I'm stopping there because we are told that these prime numbers are each less than 20. Now we need to find an example where 2 of these numbers are chosen, are added together, and the result is an odd number, but is not a prime number. So, just so we can see, if we chose 2 odd numbers like 3 and 5 and added them together, we'd get 8, and that will always be an even number if you add 2 odds together, which means that one of the 2 numbers in our answer has to be a 2. Now we can try and find the second number. So 2 plus 3 would be 5. 5's an odd number, but it's also prime, so that's not accepted. 2 plus 5 is 7, which is odd, but is also a prime number, so also not a correct answer. Whereas 2 plus 7 is 9. 9 is an odd number, but it's not prime because you can divide it by 3. So 2 and 7 is a correct answer. There are two more answers that would also be considered correct, and that would be 2 and 13, because that gives us 15, which you can divide by 3 and 5, or 2 and 19, which gives us 21, which you can divide by 3 and 7. Any one of those three pairs is a correct answer. That's the end of this second part of the video. Join us for our third and final part shortly.